discovered that sewers have been used in civilized societies to take wastes, especially sewage wastes and other types of liquid wastes, both from industries, from home, and from other sources. And then they are centrally treated in sometimes what we call the waste stabilization pond or other methods. But the sewers are used to transport and convey this waste to a particular spot for treatment. But in Nigeria, especially, it is also personalized in the sense that every house have their own safety tank where it is treated, we call it on-site treatment, there is offshore treatment. But for today, we are really looking at the issue of flood control, controlling the flood around or controlling the water because as the community develops, you discover that more roads are being built. And when you build these roads, they are solid surfaces. And because they are solid surfaces, they tend to reduce the area of land that would have absorbed water. And by so doing, they need to, this water that should have been absorbed by this area, need to find a place to go to. Okay, that is also why when these roads are being constructed, drains, line or side drains are being constructed along with it, and with other water control systems like culverts, um, manholes, and all that. Okay, so in order to achieve this, you discover there is a lot of work that goes on to make sure that there is flooding is averted, that the water goes to where it's supposed to go at the right time it is supposed to go. Otherwise, it will even help to spoil the roads, it will cause flooding, that will damage houses and properties and lives. Okay, so but you discover the conventional method that have been used in doing this is by normal excavation, excavating the ground, installing the systems if it is a precast or if it is an institute, it is cast right on the site. And after that, there is what we call backfilling and all that. But you see, this excavation and backfilling system is very, number one, time consuming. It is also, it has a lot of it has more hazards attached to it. It has it's more expensive to do if you calculate as per everything that is involved, and also the level of work is higher, and also the time of delivery is longer, and many other disadvantage. And they also look at the disadvantage of the inconveniences it will give the people because they will need to excavate and the place you see photo and everywhere, especially during the rainy season. And also it will cause a break in the movement of vehicles or around that area. There may have to be a traffic diverting around the area that as they are excavating along the road and all that and all that. You see, so but it has been the system that have been used over time, especially in developing countries. But you see, in developed countries, they have discovered that there is no need breaking up these grounds and feeling bad because on the long run, you discover any ground you take out sand and later you feel bad. No matter the compaction, especially underneath, it will never be as strong as it was. Underneath, surface might be okay, but when you go deep, depending on how deeper you go, okay. So and also when you see this that it may not be very nice, it will be better. Let me use the word. It will be better if there is a system that will help us not to break up this far original state of the ground, yet accomplish our target without altering many things. And then that is where the idea of the pipe jacking technique comes in. But pipe jacking is actually used for bigger pipes conducting bigger masses of fluid or water, as the case may be. But the smaller ones can convey cables. So it can also be used for cable, but we call that of cable micro underground piping. But when it has to do with bigger size of discharge, bigger size of fluids to be moved, we need pipe jacking. In pipe jacking, some of the dimensions might rate minimum dimension might be from 1.2 meter diameter of pipe and above. For example, I was privileged to be part of the one that was constructed in Akwa State, which as at then was the biggest in West Africa or even in Africa as at then. Okay, that was in the year 2008, 2009. It ran from the junction down to along the Calabar to River there. Okay, so what does it entail? It entails trying to drive in this pipe very deep on the ground to depth of maybe up to 5 meters, 10 meters, depending, maybe 4 meters, 3 meters, depending on the many factors. One of the factors that decides how deep the pipe jacking should go is the number one, the depth of the discharge point. If, for example, the river situation where the water will be discharged is very, very low, so remember that is the end point. So we need to know the starting point and the ending point, and then between the starting point and the ending point, there must be a slope. There must be a slope. This is the slope. There must be a distance, otherwise the water will not move. So now, this during the design of the pipe jacking, this slope is already well calculated to know what slope will be best to suit. And to decide this slope, we must know this distance from here to here, and then also know the most suitable slope that we go. Okay, so what happens is that when we decide this slope, to make sure that we don't miss out on the scope, in the surface excavation and installation, you need to call a surveyor to do the topographical surveys and all that, and keep on giving you levels until the end of. But this case, you don't need to do any physical. You do it only once, and you use the data, and you transmit to the system, and then you can now be able to monitor the data from the system in one place. Besides, I will show you some pictures about this. Okay, so now you will now use to be able to make sure that you maintain, because when you have gotten this slope, you need to set what we call the laser lights here. Laser lights, such that the laser light will be set so that it will carry that slope, and the laser light will be beaming all throughout the time of the construction. Okay, so as the okay, quickly before I continue, let me quickly tell us some of the benefits of using the pipe jacking. Number one, there are technical. The benefits is divided into two: technical benefits and environmental benefits. For the technical benefits, it helps to give a safe working and well engineered environment. Safe working environment. So work can be going on along the very major road, and yet nobody is aware that work is going on, that people are working on that deep under. Everything is going on normal, and then nobody is, except the way they will know that work is only at this entrance, because what happens at this entrance, there must be a deep excavation at this entrance to make sure that this serves as the opening place. So this I will show you from pictures better. Okay, so see what I'm saying now. This is the beginning point. So there will be excavation. That is where the pipes will now be inserted subsequently. Okay, so this is how it looks now. If we go ahead, this is the process. This is an outlook of everything that goes on. So this is the excavated beginning point. So this is the base, is where the machine is working. Now, how does it work? The yes.
Sorry.
Okay, continue. Yeah.
Now, he was asking if I
Okay, you
was
are
able
seeing
to.
the thing.
Was there
Okay.
maybe at the end of the lecture? You
I will
say,
share
yeah,
the
you share
slide.
it.
I will share the
Okay.
slide. So this is the beginning. Now this is the first. There is a hole. You discover that there is a hole here where the thing will be inserted. Now they are inserting the thing. So at this beginning, there will be cranes. There will be cranes to bring down the pipes, bring down everything that is needed, and also take out what is unwanted. For example, so the pipe jacking machine is very sharp, very sharp that it can crush even rocks. They use metal as strong as almost like diamond. So I'm telling you, so very strong. So when they put it and start, and the machine is so it's breaking everything. As it's breaking, there is a chain connection that will carry the sand that it is removing into a bucket like bucket like something that is just there. Once the bucket gets filled up, they will stop the machine and drive out the bucket. Bring another bucket. They will now discharge that one and then so that one is coming. Then they will now inside there. They are inside the machine where they are at the mouth of the machine. It has an AC like this strong AC because the place is like if you enter, even if you be afraid, the people that are afraid of confined place, if you enter, you just faint because yes, the air is limited. Now it is done such that there are pipes along giving light. They connect electrical lights along each pipe. So once the pipe enters here, there are people working here. The pipe enters here like this. So the first thing they will do, they will put all the networks inside this pipe, electrical, air pipe, and then fluid pipe. Fluid is so important because for this thing to move, because this is very well compacted. So even after the machine have create that space to move, you still need fluid to lubricate that so that without that fluid the thing will not move. One of the name of the fluid that is very important in this is called bentonite. Very important, bentonite. So if there is a cable for fluid, a cable for air, and a cable for light. Most importantly, so they are connected before this thing will start being pushed inside. Meanwhile, the laser jet is always constant there, showing that the thing is at the right, showing them the right direction to go. Okay, so that's how it goes. So they drop the pipe here and they start pushing the pipe here small. And after that, they will keep on dropping other pipes. And this thing keep on excavating. They are removing the sand. The thing keep on going deeper. As it go deeper, for the one the Jolopedia did, the sizes were 2 meter diameter pipe and then 4 meter long, but it can differ. Now take note that this pipe must be very strong. It is a precast pipe, concrete pipe. It's so strong. Why does it need to be so strong? Because it's going to enter to fit in a vacuum space that is created, and this vacuum is still under high pressure of but all the other. So if it's not strong enough, it may break. It will break, and then that will be the end. So it's always very strong to the extent that some of them can be as thick as 40 cm. That's 400 mm thick, 0.4 meters thick. So very thick. So it will go. Now it's not only concrete pipe that I also use. Metals can also be used. But you see, when it has to do with channeling water, water and iron. So rust. So it's concrete that is more preferred when it is iron. Now let me tell you, this system is mostly also used even in crude oil this thing, but they tend to use iron instead of concrete. Okay, when you hear high pressure pipe area, it is that. Are you getting that? So it's similar to what is so the thing can go, but the only thing is that there will be interjections where maybe at 100-meter interval or 120-meter interval, they will put like an interval, something strong that should be there to make sure that they will also put something like a manhole where people can enter from that 100 meter, very small. Okay, so they will go again another 100 and put. These are necessary also for servicing purposes. Okay, so they will keep on putting that manhole to the end. Okay, so that is how the thing goes until it continues. Now, this when it goes, this is now the end point. They have already made a hole there. The end point will also have this kind of excavated this thing, so that they can also be able to bring out the digger from it. So that's what is happening here. So when it gets closer to this, it will enter here, and then from here they are taking it out as they brought it in here. They are taking it out. Okay, so that is how this thing goes, the pipe jacking system. That's how it goes. So quickly, I wanted to say the advantages. Number one, it's number one. Number two, it's structurally very sound because it does not have a lot of disturbances and all that. So it maintains its structural soundness for a very long time. Number three, it continuous ground support, continuously supports the ground. You don't have a lot of things. Number four, minimal joints because the thing is continuous. The way the pipe is constructed is such that here will have a small that will enter into the mouth of the other one. So it is over, it's lap together like you think that it's just one pipe. Okay, very well. And then they still do some just to try to seal the thing because this one will not enter very completely before they will put this one. So when it gets here, they will still you do some kind of sealing after they have driven this one to join together. They will use a mortar, very smooth mortar to make sure that it's well smoothing. Okay, then number four, gasket oriented flexible joints. Gasket oriented. So that's the joint I'm talking about. So that in case of servicing, it can easily also be removed, even though you may not observe that it's a but when it's time for servicing, it's always flexible. Then maintenance free. You don't need you can for over years, you don't need to even talk about it. It's just working. But for the surface own, you must have to desal from time to time because sands and all these, so the maintenance is higher than and more frequent. This one, the maintenance is so low. Let me tell you why. Sometimes, yes, water and sand will mix up and coming, but because of the pressure of the water that is coming, it will even push both the sand and the water at once. The water has some pressure. So when no matter what it is, if you carry stone, everything, if you carry it. So where it may have some maintenance, may be at the outflow. That's where is the river. So the river, so we may have to descend the river from time to time. But for the inside, it looks very smooth. Okay. So then finally, good flow characteristics. It continues to flow. There is no hindrance to the flow. Then there are also environmental benefits. Number one, it reduces destruction, and number two, it reduces damage to services. See, normally, I've been privileged to work on many projects and Port Harcourt, even in Rio and many other places. I discovered something. Whenever road construction, especially dualization, is going on, so MTN they have their pipes laid underneath. Globe, MTN, that's why we don't see them. Our own electricity is the only thing that is up. All those MTN, they come with their, which is the right thing. They are buried underground as cables. Okay, so that's why when you see Jilobe, they are also constructing a dualized road. They make provision. So they make provision for it. They will make provision, dig a particular distance and cast it all along the whole stretch of the road. So that all they need to do is to just insert their cables along. You see, so the Jilobe will bury the pipe, cover it, concrete it along the whole entire stretch. Okay, so but assuming there is a road that maybe already have this thing, MTN have penetrated into communities here and there, rural area because people are still making calls from there. Are you getting? They have also buried their cables all along there. Now a road now is about to be constructed there. You see, it will entail, cutting some. Even while we were working in those days in Jilomedia, we used to cut their distance and they will come for compensation and all that. So That one can say management, they don't have, they settle themselves there. Okay, so that's the thing. But this one, you don't need to damage anything because it goes far below. You don't damage MTN, you don't damage telecommunication or any other services. Okay, so then highway protected. So if it, because of the depth, so highway is going around this depth, and then this is almost maybe 5 meter or 4 meter or 5 meter, or even 6 meter, or as high as or low as depending. No, 6 meter is too stable building down. So nobody will even know that is going on. Okay, there are videos you can check, you see work is going on. Nobody, they will only barricade only these points. That's where, so that's where electro traffic situation, they will just one instead of driving two, they will be one. So after that, all throughout the entire stretch, you will not see any sign of work going on. So that's the then 90% less vehicle movement. 90% less vehicle move. In other words, if vehicle will continue to move, almost all vehicle will continue to move, and then less spoil. It does not spoil easily, and then less wearing material. Normally when you are doing, I talk about backfilling, so you need to use material for boropi. That's what we call wearing material. So but here you don't need anything. The only material you are doing is the one you are removing, which there is a standby tipper. So as they are removing the thing, they are pouring it directly on the tipper. I pour and pour and pour and pour. When the tipper is full, that one go, another tipper is already packing, waiting to be filled again. And then now I'm going. So but there is no backfilling. So and many others. So it is a very good technology for our time, and it can be adopted anywhere. So as engineers, as technical people, as architects, we should also emulate good technologies like that. Thank you very much. And, I'm sorry I've exceeded the time. Sometimes it's difficult to keep to 20 minutes. So question, ask question, contribution, any other.
The question I have is considering that it's used for drainage, right?
Yeah,
Water drainage.
yeah,
So, like, if it's along a highway,
yeah.
how do you channel water, like, to enter it? Is it like at a culvert that you have it, where
Okay,
you have major water, like water going there
okay,
and then, but how about like on the side along the road?
okay, very good. Now, already, the function of the pipe jacking is to take the water to the river, to the main outlet. So now, the road is, the development have already created a situation where the city is already planned with some surface this thing. Minor, because you cannot do pipe drainage, it's very cost implicative at the beginning, alright. So those other waters will now be channeled to it
Okay.
in one place. You need to do it more than one place, no problem. That's also the reason why they give that 100 meter interval they give, so that in case they want to channel any other one from another place, they can also be able to channel it to that place. So the water, once it is channeled, of course, yeah, this one is very costly. You cannot run it around the whole city. So when you have run those upper ones around it, so this one, and the good thing about it, can carry as much as, depending on what is between you decide the diameter to. So 2 meter diameter, the one that you elevator did, it was big enough. If I'm walking, if I put hand like this and I'm walking, there's still space. So it's very big. So actually, that's this some kind of technology that some people have, but then they call it underground houses. They do it and they live there. You will not know that people are living, and they tunnel it so that they can also come out to another place and another. But that one was not for channeling of water. But you can not only for channeling of water, but it's very critical also for channeling of water. The reason is because of this: water is very devastating. Water can cause untold hazards when it surges. So, but when you have some systems like this in place, you are rest assured, no matter what comes, all you need to do is to quickly channel them to the appropriate. Then that's it. Even if it is head drain, you can still find a way channel head drains. So you now flow. So that is the advantage.
You mentioned that there will be something like a warhead
Yeah,
that will be
escalating.
that,
There's a
that,
name.
yes,
I've forgotten the name of that.
but
Yes.
now the pipe, how do they connect the head
With the back.
with the pipe so that as it is going, it is also
Yes, it is
driving?
connected. Yes. Now the warhead is determined after the pipe diameter has been determined. So the pipe diameter we are talking about is the internal diameter. So you now add the concrete cover to it to get the external diameter. So the warhead, the machine head that is is as big as the external diameter of the pipe. So you get one that's exactly as big as, so that as it's going, they will also connect it like this. Connect the lights, connect the air, connect the fluid to it. So as it's going, it's also lubricating. The fluid even helps it to lubricate this before it will even start breaking, in case some places are too. So as it's going, it will not be pushed. There's another one here that will be pushing it. It's always there. So yes, it's pushing the pipe. It only has capacity to push the pipe from here to here. So once it reaches here, it has to come back. Then they will drop another pipe. Then they will wait, they will connect all those things. As soon as they finish connecting those things, you push it again from here to here and come back. And then they will drop. So it is sensor. So it will be fitted, this thing will be fitted to it as normal. And then you will not allow to reach that final bus stop where we have this thing, where it will not be taken out. They will not use that and take it out from there. And then only the pipes will now remain.
Last question. Now the lighting, is it inside
Inside the
the
yes,
diameter?
it's inside the diameter of the pipe inside. So inside you will see it is spaced maybe 10 meters interval or maybe 5 meter interval. The light is so necessary because it's very completely dark there, no air, no light, and
So
so
like the provision for ventilation.
ventilation. So the AC pipe head and then the lights at the intervals. So it is connected from this first one. So as this one is going, they want to break another. They will connect the other one first before they drive it in. They will connect it so it is a continuous process. Then when we are through doing this thing, maybe this thing will go 1 kilometer down or 2 kilometers depending. Then after we have come out here, then we can now start loosening this thing one after the other, one after the other, one after the other. That's how we do, so that the thing will now remain. Then we will now take time and pass it inside. Now there is ventilation at intervals of 100 meters.
Okay.
And also there is ventilation, so nobody will be afraid of the air will be coming small small time. Before, no way, only from one side. So air cannot cross, ventilation is not there. But now, after it there is cross ventilation. So people can now walk without, but they still need the light to, even the AC, but they can manage even without distance and be able to see. Because you see light at the end of the tunnel. But you see the light. So immediately they will do all the patching, all of this, then they will dismantle everything and the thing will now remain.
Does it look like this?
Yeah, this is the mount. This is the mount. I have forgotten the name. Yes, I will check for the name. Yeah. The mount. But there are different types of it. This is just one type of it. There are different types, different designs, but they are too strong. They like almost like a diamond. That thing is so expensive because of diamonds are expensive. Things that can be able to cut rocks, they are very expensive, and they guard it like no man business. So that is the another question. Yeah, we could have written it down. Okay, you have gotten it. Okay. Together. That is how it's joined. It's joined at this point. It's joined at this point. Any new one that comes, they will join it there. Okay, thank you very much for having me. God bless everyone. Thank you.